Right? That's the SOP. Instead of finding SOP, we just know B of K and more than B of K right here. So this is an X of K or X of T B of K. So we had to, yeah, so what we should have done is X of T 1/2 plus negative 3 sine
KW not T, which it would be different because the KW not would always change.
But then you keep
The T get thing, I'll show you.
what you're saying that okay.
No, T's different. T and K are the same thing.
So
Solve it without.
Well, you just do the sign of then KW not, which is equal. Oh, well, you go on. It's the I mean, the amplitude will change. The amplitude.
so this was
I'm saying your X and T. This isn't your X and T, but this is fun.
But how do you do the 1/2?
1/2 at the end. What do you mean 1/2? The A is 0. That's A is 0.
So will this
Yeah, that one is 2. No, it's just staying at the same amplitude, right? No, mine changed. Mine did the same thing y'all did. Except you guys can do 8 or
Quiz 9 and 10 in class. Because I had 2 zeros put in, and I've been in class every day. I just wanted to see if like I missed it.
Well, I always keep the quiz, so just send me an email with usually
Because I know,
that you can dig up the grades. So this maybe I didn't see a paper.
or maybe I was thinking maybe I missed the attendance sheet one day and you just based off the
No.
attendance.
Okay. Even that I don't look at the papers, I didn't want it.
Okay, I'll just send you an email because I just wasn't sure. I mean, I understand that.
I got the same coefficient as always.
Yeah, I will check again.
So that's
Did you write your
fine with you?
I usually do.
Okay. So just give me email, I will check back again.
Wherever your B of K term is and all this. Yeah. And I just pretty much got this just equals -2. Did you answer this? K squared? I don't even know where to go. Yeah. And then it cancels out. Yeah, because whenever you, I forget what happens, I can't remember off the top of my head, but something where the K and pi are going to be outside.
Good afternoon, everybody. Do you need extra time to do the pre-lab? Do you need an extra day? All right. Well, just extend one more day to do it. And just I'd like, because I mean, some students, they asking questions, so I want to make things clear. The function that you have, the important thing that you find the equation of the function. And I'm sure everybody is going to pick from t equals 0 to t equals 3, the period. It's 3 seconds from 0 to 3. And the integration will include x of t when you get the average, all right, and over the period. And if you want to find, for example, ak, you will see 1 over t naught, the integration over the period t naught, x of t cosine k omega naught t dt. I was asked a question that what is x of t? Is it the amplitude of the signal? No, x of t is the function, the equation that represents the signal in the period from 0 to 3. So that's, I mean, when you have the amplitude here is equal to 2, you go to the y-axis, and that's x-axis. Of course, I mean, it's, and the 0 axis is like something here in the middle. That's the time axis. And that's x of t. So you got to find the equation of this straight line. Let me make it clear here. The value at the top is equal to 2 and in the bottom -1. So we have a straight line. And the time is equal 0 and the value -1. And in the top, the time is equal 3 and x of t is equal 2. So using these two equations, I think you'll be able to find the equation of the straight line. I can do it in easy way. I will say, okay, that's 2 from -1. The vertical displacement is equal 3. And also the horizontal is equal 3. I can say that the slope is equal 1. And it's positive. So I'll say x of t is equal 1 times t. And then I don't know about the y-intercept. How I find the y-intercept? Let me just write now, this is x, not to confuse you. At t equals 0, what is the value of x of t? -1, right? This is the point. When t equals 0, x is equal -1. So you can put it in this way and find the y-intercept. So c equal -1. So, and obviously, it's intercepting y-axis at -1. So x of t is equal t minus 1. That's the equation you're going to use when you integrate. So you multiply t minus 1 times the cosine and t minus 1 here, integrate, and you go ahead and you continue. That's what you're going to do. And bk will be the same. You multiply t minus 1 times sine, and then you integrate. And I give you the formula sheet in the Fourier system. I give you integration of t power exponential t power cosine t power sine. Just you substitute. Find what's a and b and just substitute. So what's the average value? Average value, I mean, you can get it by this one, a naught, or you can get it by area. You can find the area, the positive area, negative area. That's the negative area. That's the positive area. You can do that. We do integration. Both are the same. You can do both to check if you understand how to get it by the area. That's, I mean, it would be helpful. Determine the coefficient of the trigonometric Fourier series, AK, BK. Already we talked about that. Write the first 8 terms. First 8 terms means that you have a naught, that's one term. And then 7 terms left. Would be like a1 cosine omega t b1 plus sine omega t omega naught t, and then a2 cosine 2 omega naught t, the second harmonic, like that. So I mean, what I'm trying to say that you write just the first 8. If you exclude the average term, so you got like 7 terms in the summation, you know. Sketch the amplitude of the first 8 terms of Fourier series on line spectrum. That's important. Now, how you do the line spectrum, it should be the amplitude. So it will be easier if you can convert the trigonometric Fourier series into compact form. Compact form that we just said. Let me write, I mean, what the trigonometric series, the normal one is a naught plus summation from k equal 1 to infinity, ak cosine k omega naught t plus bk sine k omega naught t. That's the normal trigonometric series. And if you have in the compact form, it would be only one cosine. So you can have it like a naught plus, no, not a naught. We use c letter, okay? C naught plus the summation of ck cosine k omega naught t, exactly like that. And then you add the shift, theta k, from k equal 1 to infinity. ck, we said that you can get it easily by ak square plus bk square root. So you have a1 and b1. a1 squared plus b1 squared, you get c1. a2 squared plus b2 squared, you got c2. And so if you have, maybe you don't have to be 0, you just write 0. And you continue. That's how you get the magnitude, ck. And then you need to find theta k. And we say that theta k, it's equal to 10 minus 1 negative bk over ak. But I said you have to be careful. Ak is positive or negative. If a is positive, leave it like that. If a is negative, you add pi. Why? I don't just to memorize thing. Look at the unit circle. And when you multiply by negative or negative b over a, if you do anything like that in the first quarter, what you have theta, that's theta. You have, that's the real part and that's the imaginary part. Both are positive, so no problem. You find the tangent, just divide b over a, because b represents the imaginary part. That's b, and that's a. What about if in this quarter? In this quarter, you have b still, a is still this theta. A is still positive, but b is negative. So you can get it also by 10 minus 1. It will give you negative, right, like a negative 30. The problem happens if a is negative. So when a is negative, you are here. So, and b is negative, so you are working here. And the angle will be counted from x-axis up to here. That's your theta. So to do that, just if you can get the angle theta by itself without sign, just positive values, and then you add this pi. This is the pi. To avoid this problem, I just give you something very easy. You can just use a tan 2. I give you this function, and you can use it in MATLAB. Just plug it, put it, it will give you. You don't have to add pi, nothing. Just give whatever you get, put it there. And you put the imaginary part. I think I give the form of this for you. A tan 2. Yes, 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 I give it to you. So that will make it, I mean, your life easy. Just, I mean, you put it in MATLAB, 8 and 2. You don't have to add pi, negative pi, use it. Some calculators they do have it, some they don't have it. But I mean, if you have MATLAB from you don't use MATLAB. So that will be, once you get, I'm not asking for the angle even this one. I'm asking about the line. Oh no, line spect, you will do both. So you will have omega on x-axis and y-axis will be ck, the magnitude that you just calculate. So at each, like that's 0, it means DC component. And this one, omega naught, the fundamental. Omega 1, omega, so omega, this will be the fundamental. This is, I think, with the second one, omega 2. All right, called omega 1 fundamental, and this omega 2, omega 3. Omega 1 is equal omega 1 is equal omega naught, and then omega 2 you multiply it by 2. Omega 2 will be equal to omega 3 will be equal 3 omega naught, and so on. You can put k instead of k of omega. That's fine. You can k again. That's okay. I'll accept it. So that will be the magnitude. The angle will be theta k omega or k. Whatever you calculate for every component, you put it there. It's against omega. Okay, so you can make a table like k omega, and then you have AK, BK, and then you have CK, theta K. You can make this table just to make your life easy. And then whatever the value you have, let's say, for example, you are working at K equal 3. K equal 3, so what's omega? Related to K. Omega is equal K omega naught. And you have omega naught. So if it's 3, you put 3 omega naught. Whatever the value of omega naught, the fundamental component. So you put it there. So you have here 3 omega naught. You put the value. If let's say that if omega naught is equal to let's say it's equal to pi, for example. So you have 3 pi. Now we find AK. Let's say that you find AK is equal to maybe AK is given like 1 over K or 1 over pi K, and BK is equal to minus 2 over pi K. If it's given like that. So if you are working with 3, you put 1 over pi 3. So you have AK 1 over 3 pi. B would be minus 2 over 3 pi. You got AK and BK. You have the equation square AK, square BK, square root, and put it there. So you will have CK is equal to the square root of 1 over 3 pi square plus negative 2 over 3 pi square. You got the value, put it there. You want to find PK, theta K. I mean, theta K will be equal to A tan 2. I will advise you to use this function and put the value of B minus BK and BK, minus BK and EK that you calculate here, it will give you that theta. In radian, you want to convert it to degree, put it in degree, but you have to mention that this is in degrees. That's all. Doesn't matter radian or degree. That's it, and you do that for the 8 components that you have. And maybe you'll find some component equals 0. Like if you have 8 components, you have A0. You have 0 component, the DC. Then you have 1, 2, 3, 4, 5, 6, 7. Maybe you have only the odd. So 2, 4, 6 would be 0. Maybe I mean I don't know what you are going to have. If it's odd or it's even. So that's the way you're going to make the table, and then you sketch. I think that's all. Yes, that's all. That would be good exercise, and to do the it would be good, because I mean this is not like, I mean we did in the lecture the square, so you find 1 minus 1 simple, so you can understand. Now we are working through it. You will get it. Yes.
If we submitted last time, we like fix it, can we resubmit?
I said I'm going to extend 1 day, so you can do whatever you want.
And also, I know you said something about that report, like the format. I think you wanted to-
Yeah. Okay, let me mention that. That's right. I mean, because I mean, obviously, the Fourier system is like changing the format that you're using, so it's not fair. I mean, you get deducted at some point for, it's not your mistake, it's the Fourier system. So I'm going to go back and fix your grades for the first lap. And from now on, when you submit your report, do it PDF, the right format, because we check. We found that the PDF doesn't change the format. We tried rich text format. Usually, many systems, when you use RTF, is good, but it's not good. So it's something, I mean, weird about D2L system. So you do the report with PDF with the right format. Now I want to check your program. You can submit the program in a separate document than PDF in Word. And doesn't matter its format, not the result, just the code. That's all. So I can copy and paste them both. Because I mean, when you, it's hard. I think you got to download it or something like that. So just I mean, put it in Word, and I will just.
So you don't want to take pictures, but you actually want to copy and paste the code from Word.
No, you will do, but I mean, when you will do, and you convert to PDF, I can't copy and paste in MATLAB to check. Do it, and then extra document on the side that has only the code without the result in Word. Look, yes.
Ian, so the Word document that you've already. Okay.
It's just, I mean, I think, yeah. So just the PDF is like the report, the formal report. And just to check your code, it has to be like, I mean, another copy of Word, no result, just the code, just the code. You don't have to worry about its format even. Just use this program for doing that. That's it. And then the second, if you have a second program, just please start from new page. That's all. I'm not going to count in any format for the code for the Word document, but the PDF that I'm going to take. Okay. Everything is clear. Yeah.
So are we going to resubmit the lab 1 to lab 4?
No, you don't have to. I'm not going. Just I'm going to ignore the shifting.
Okay.
Yeah. Any question? All right.
Sure, I do have a question.
Yeah.
When you're transitioning to like say f of t equals
T minus 1. Yeah.
no, not t minus 1. It's like a0 plus the rest is like the function, and then when you get rid of the ak and just have the bk, do you say negative k of you say negative k or no?
No, I didn't say negative k. Negative a of k. So if a is negative, then you have to add pi. But I said if you're going to use the function a tend to, you don't have to worry about pi or anything like that. I was talking about the theta. Okay. Any more questions? I'm going to post the. I'm trying to do the model answer of the quiz, because it's very important to understand. I mean, how we can solve it. It's like, I mean, it was like I'm asking about the confusion in separate question to make sure that every part you got it. So I will post the model answer. Well, today we're going to do complex exponential Fourier series. And that's important because from exponential Fourier series, we can move to Fourier transform. What's complex exponential Fourier series? The original formula that we did, x of t equal a naught plus the summation of k from k1 to infinity, ak cosine k omega naught t plus bk sine k omega naught t. That's the normal trigonometric Fourier series. And we did it in a compact form, like instead of having cosine and sine, so we did only in one. So I say it's equal c naught plus, and then we have c of k cosine k omega naught plus theta k. That was a good move. They said, okay, let's just move and make it like expression of exponential. Why they did that and how they did it. We know from complex number that e power j theta is equal to cosine theta plus j sine theta. And if you want to find cosine by itself, cosine theta is equal 1/2 e power j theta plus e power minus j theta. If you want to find sine, will be equal to 1/2j e power j theta minus e power minus j theta. That's called Euler formula, and that's how. So they apply these things to the trigonometric function cosine and sine, and then they replace cosine by this formula, they replace sine by this formula, and then they got the exponential form of Fourier series that we're going to explain today. So how it's expressed? It's expressed like that. The same function x of t will be equal to, we use the term d, some textbook, many textbook do use c, doesn't matter, d naught plus the summation from k minus infinity to infinity except at 0, because we separate it here. Some also, I mean, they just include d naught inside. It can work, it's okay, but I'd like, I mean, to make it separate. So dk, the coefficient dk, e or j k omega naught t. So instead of using cosine term plus sine term, I use e j theta. And you look at that k omega naught t, look at that one, and look at this one, k omega naught t, the same. But you have cosine plus sine. So I make it in one term, e bar j. The beauty of that, you have dk ready. So you can do the line spectrum without doing anything. Just you get the dk, and dk, by the way, in general, it's a complex. It has a magnitude and it has an angle. Take it, the magnitude, and sketch your line spectrum by a magnitude spectrum, and take the angle and make it the phase angle spectrum. So that's, I mean, just ready. You don't have to do anything. Just whatever you get dk, that's going to be used in line spectrum. That's why they move. D naught is exactly the same as we did here, because A naught, C naught, D naught, all are the same, the average term. Some textbooks just leave it. Here I write k not equal 0. But if you want to have k equal 0, you can cancel D naught from this equation. You can write like that. It's right, it's correct too. From k negative infinity to infinity, dk e power j k omega naught 2. It can be like that too. Correct. You can get, how can you find dk? That's the most important thing. To find the dk, it would be integration, as usual. It would be 1 over t naught, the integration over t naught, and the signal xt, the same as we're doing with ak, bk, ck, the same thing. But every time when you multiply, It's according to the terms that you have. Here you have cosine and sine, so you multiply by cosine and sine. Here you have e power j, you are going to multiply by e, but instead of positive j, negative j, k, omega, no t, dt. That's how you find the coefficient of complex exponential Fourier series. Okay. When you do the integration, obviously, now we just have to look what formula you're going to use when you integrate it. What do you expect? Well, e power minus j, you can say in general, it's e power at. And a could be minus jk omega. And x of t may be constant. So you should be able to integrate this one. So you should be able to integrate the following. Possible that you can have a straight line. So you should also be able to find the integration of t, aat, dt. Yes, you can have sine wave and cosine wave and too much, but I'm not testing math. I don't want to test in math. And actually, I will not find sine and cosine. Usually I have like square wave, triangular wave, so two things like that. So I'm not going to get outside that. It's either that you can integrate this one or integrate this one, and this integration is given. And I will tell you. I mean, now how you find the integration. There's a formula that I proved under there. E to the power of at, and a you can solve by anything. It will be equal to at minus 1 over a squared multiplied by e power at. That's the integration that we're going to use if you have. This is the most difficult one you're going to have. It's still simple. All what it's supposed to do, if you have from the limits from, for example, 0 to 3, you make it like, I'd like to do it organized. So what I'm going to do, if you are going to integrate this, let's say from 0 to 3, I want to do that. I will call this I of t, integration. So when you find this will be the formula, and then one time you substitute by 3, one time, so we'll say it's equal the integration when t is equal 3 minus the integration when t equals 0. I'm going to use this. Why I'm doing that? So I mean, I can do it in separate line. 1, 3, what's equal to I of 0 is equal to, and then I subtract, because when you put it in one line, you will make a mistake. I will make a mistake. Just I'd like to organize. I mean, that's I of 3, but I only understand when you see it in the document. I3, it means the integration, the value of integration when t equal 3. I of 0, the value of integration that they did when t equal 0, and then I subtract, I get I of t. That's right. Okay, so we'll agree about this notation together. Well, there is something else I want you to understand. There is a, and I'm going to put in the folio, this signal, important signal that you will see it a lot when you study in the sync. Anybody were exposed before to sync function? All right. Sync function, it's simply sync t, for example, it's equal sine t over t for t not equal 0. When t equals 0, the value is 1. But this is unnormalized. We call this unnormalized. Unnormalized is sync function, and sometimes you call it sample function, SA of t, to distinguish between unnormalized and normalized. Sine or sync pi t, that's normalized. That's normalized sinc function. How it's defined? Sine pi of t over pi of t. And that's for t not equal 0, and that's equal 1 for t equals. Now, we did the all information that we need before we start. So, because we are going to need the thing. I will start now to explain example how we can find d of n, the the terms for exponential. Example also be easy. So let's assume that we have a square wave. That's the time.
Sure. Is it possible you just scroll a little bit, like to the last equation?
So in this example, the function is defined as square wave from negative 0.5 to 0.5 is equal 1. And then I'm moving every half till I reach negative 1, and then I have another 1. That would be, that's negative 1, I'm sorry. So it'll be negative 1.5, right? Negative 2, negative 2.5. Okay, let's make it clear. And it will continue. That will be 1, that will be 1.5, 2, 2.5, and so on. That's x of t. It's required to determine the coefficient of complex exponential Fourier series, which is dn, and flat line spectrum, which consists of 2 spectrum, one for the magnitude and one for the angle. So that's the question. So expect that the next lab will be on this topic. We'll do the same thing that you did with trigonometric. We'll make an exponential. That will be good exercise. Now, how can you do that? The same steps we did with the trigonometric Fourier series, we're going to do. What to do first? First, you find T naught, the period. So the period T naught. So what is the period? This one. Huh? Somebody say 1. Anybody else? Huh? 2. That's right. It's 2. Because I mean the period you can say start from here up to here, and then it will be repeated. Or if you wish, if you say I'm starting from this point, so we'll go down to 0 and then go back till here, right? That's 2. So it's 2. So the period is equal to. What about the fundamental frequency, omega naught? Omega naught is equal to pi over T naught will be equal to 2 pi over 2. It's equal pi, radian per second. All right. Second, you should write the function, but we have an easy function. I will just define it like that. X of t equal, define it over one period. So I would like I need to choose, it looks to me it's an even, all right? So I'll say it's from here to here. So it's equal to 1 when t greater than or equal to negative 0.5 and less than positive 0.5, and 0 for t between negative 1 and negative 0.5, and 0 also when t greater than 0.5 and less than 1. You can define different way, of course. Maybe somebody say, no, I will start from 0. Yes, that's right. But define over one period that where you're going to integrate. Why? To be ready. So we did t naught, omega naught, the function, you know the equation. If straight line, find the straight line equation. But define over the period where you're going to integrate. Then find the average term. The first thing, the average term. I'm going to use the normal one. I will say d naught is equal to 1 over t naught, the integration of the signal over the period. So I have 1 over 2, and the integration I'm taking from minus 0.5 to plus 0.5, and it's equal to 1 dt. So I have half times t, and the t will be from negative 0.5 to positive 0.5 will be 1, so it's equal 1/2. Can you do it graphically? Yes, it's easier. Doesn't take time. Here the area. What's the area of this square? It's 1. The height is 1. The width is 1. 1 times 1 is equal 1. It's spread over the period. 1 over 2. Half. Finished. Why I'm doing this integration? Because maybe we are going to have like something weird exponential. Yes.
For the x of t, is that like a t or like a negative 1 at the top over 0? Like the two functions, like the two statements.
And.
No, like x of t is like the bracket.
X of t.
Yeah, x of t and then bracket.
Yes.
Either t over 0 or.
It's equal 1 when t greater than negative 0.5.
Okay.
Is this the one you asked about?
Yeah, I was asking if it was a 1 or a t.
Oh no, this t. Yeah, the variable t. So now I got the average value. Now I go for the term, and it's one term but involving complex number. That's, I mean, heavy stuff in complex number. Let's see, and even it's 1. What is the definition of dk? Dk is equal to 1 over t naught, the integration over the period t naught, x of t times e minus j k omega naught t dt. The period is equal to, and I'm going to integrate from minus 0.5 to positive 0.5, and x of t is equal 1. Easy. E power minus j k, and omega naught is equal to pi t dt. Okay. So I have 1/2, and we know the integration of the exponential. It's the same thing divided by the factor on the top. So e minus j k pi t over minus j k pi, and the limit from negative 0.5 to positive 0.5. So I will take 1/2, and the 2 I multiply by this would be 2 j k pi. How we get rid of the negative? I'm going to exchange the limit, right? So I will just write like e power minus j k pi t, and I will just flip them. Why I flip them? Because it has a negative, and just you take out the negative, you change the limit. That's a very simple rule. Now I will start substitute. 2j k pi. First, I substitute by negative 0.5. Negative 0.5, negative will be positive. E j k pi times half means pi over 2 minus e, and then I substitute t by 0.5, so you have minus j k pi over 2. All right. Remember that k pi over 2, I mean, if it's bother you, you can call it anything. What about if you call it theta? Right? K pi over 2, call it theta. So if k pi over 2, call it theta, so what's k pi? 2 theta, right? If you want to make it easy, you know, it looks easy. I mean, because I know that when you say j, k, it's just like it's annoying. So I say 1 over 2 j k pi. K pi I found is equal to theta. And this one will be E j theta minus E minus j theta. Yes. Now, always try to make it look nice, you know. It's psychology, it affects, really. When you see it like that, you see it with jk by just. Now, I can say it's equal 1 over j4 theta times E. Oh, okay. Now, let's go to that. E j theta minus E minus j theta. Already explained in the beginning of the lecture what we're going to need. Let me show you, the Euler form. That's here you go. What I have first, let me remind you, it's the difference between E power j theta minus E power minus j minus E. So I go back to the formula I have to look at it. And that's what I need. Oops. That's what I need, right? So I can tell you now, from this formula, I can say that E power j theta minus E power minus j theta equal to 2j times sine theta. 2j sine theta. Right? So I'm going to do that. E power j theta minus E power minus j theta, it's equal to j times sine theta. All right. So it's equal to 2j sine theta. Now j cancel with j. And 2 cancel with 4 will become 2. So what you get in the end? You got sine theta. Yeah. What?
When you flip the thing to make it you flip the integration, that -5 should have been the first E term, right? So
I got rid of the negative and I changed the limit.
so should the first E to the JK pi over 2 be negative and the second?
No, you have negative and negative will be multiplying it post. Oops.
I apologize.
And the screen got mad at you. What's happened? Okay. So we have sine theta divided by 2 theta, right? 2 theta. I can write like that. So 1 over 2 sine theta over theta. What is that? Sine theta over theta. Sinc function, yeah. So now I can say d k is equal to 1/2 sinc theta. Well, it's just way of abbreviation, and the reason so when you see sinc function, you know what it is. It's just sine something over the thing. All right, now I can put it back actually in the original form, because what is theta? Theta is equal to k pi over 2. And let me just go to the original formula. Sine k pi over 2 over k pi over 2. I'm just trying to go back. And when you do that, what does it mean? Sine pi k over 2. And you have 2 in the top, so the 2 will be canceled. So it's like 1 over k pi times sine pi over 2. So that's our dk in k, and in simple terms that we know. I can now get the all coefficients. Like if you put k, then you can find dk. So if you put k equal for by the way, there's something here. Did you observe when we are using the exponential Fourier series? What is the formula here? Let's look at this one. What do you observe? K does not start from 1. Start from negative infinity. So you will have d1, d minus 1, d2, d minus 2, d3, d minus 3, and so on. So we're going to have like a negative frequency. there is something physical called negative frequency? No. And if you go to the Google and just write negative frequency and the exponential Fourier series, you will find a lot of people, I mean, in many platforms, they are discussing, they try to find meaning for the negative frequency. But it's mathematical. And it's symmetric. I'm going to talk about symmetric. Like, I mean, the magnitude on the right is equal to the magnitude to the left. It's an even. But theta is different. It's odd function. The height here is like equal height, but flipped. The sign is flipped. So is subsequent negative frequency? No. Some people try to find like it's just mathematical expression. Maybe the best explanation that I read about that is like saying, I mean, if you have frequency, if you have wheel and rotating in this direction by 50 hertz or 50 cycles per second, if it, when it's flipped, you call it negative, but it's not the definition. Frequency definition is number of cycles per second, didn't say direction. But some people, they try to give it physical meaning. That's okay. All right. Anyway, so you have negative and positive. So when you do your table for K, let's say you want to find 3 terms. So we write here -3, -2, -1, 0, 1, 2, 3. If you're asked about just these terms. And now, let's see. First, we got the 0, d0, it was half. So that's equal half. Okay, if you are asked to find all these values, should you calculate for the negative and the positive? Yes. So when substitute by 1, when you have k equal 1, what do you have? When you have k equal 1, so you will have d1 is equal to 1 over pi sine pi over 2, which is equal to sine pi over 2 is equal 1. So you have 1 over pi. So you have 1 over pi. If you have k equal 2, so d2 is equal to 1 over 2 pi sine pi. It's equal 0. So obviously only you are going to have odd numbers. When you have k equal 3, so you have d3 is equal to 1 over 3 pi sine 3 pi over 2. That will give you negative 1 over 3 pi. So it's odd, and every time you are flipping in the odd positive to negative, you have your negative 1 over 3 pi. Let's substitute by the negative values. You can do that. Do you have other way that make it fast? You don't have to do calculation for negative? Yes, there's a way. What the way? Let me show you what you're going to do. Just let's move this one down. What I'm going to do, I'm going to find the magnitude and the angle. How you do that? You tell me there is no angle, there's no J, there is angle. I'll tell you how. 0.5, that's the average, doesn't have frequency. So when you write here, you say that's the magnitude and that's the angle. The magnitude, it's the same for the DC. And the angle is 0 because it's DC. DC doesn't have phase shift. Now look for the fundamental common. 1 over pi, the magnitude is 1 over pi. And the angle is 0, right? When you have positive sign, what does it mean? The angle is 0. Let's, for 2, simple. For 3, negative 1 over 3 pi. The magnitude is equal, just a second, 1 over 3 pi. What's the angle? What's negative 1 means? 180 degrees, pi. All right, so now I did the magnitude and the angle. Now, once you have the magnitude and the angle, you go for the negative. Look for the negative, what you're going to do. Negative 1 will be like 1 for the amplitude. Just, where's the amplitude? That's the amplitude. Just make reflection. 0.0, you have 1 pi, you have 1 pi. You have 0, you have 0. You have one of them. Just mirror the magnitude. What about the phase? The phase, no, it's odd. You reflect and multiply by negative. So to the right of 0 is 0, 0, 0, 0. That's easy. Pi, negative pi. And you're done with, as mentioned, you got like 7 terms. All right. And now we can find, you can plot the line spectrum. But first, let's answer the question.
What you call those two components? Those last two?
This one and this one, we call the magnitude of the coefficient, and this one the angle of the coefficient. Yeah. And now we can sketch the line spectrum. If you want to do with the frequency, okay, let me do with the frequency. How you do the frequency? I should have it space here, omega naught, but I'll make it in the bottom here. Yeah, excuse me for that. I should do it just below k, but let me write omega. So omega at 0, it's 0. At 1, it's the fundamental. What's the fundamental frequency? Pi? All right, pi. Yeah, sure. I don't. Let me see what we got here. Yeah, pi. Just all right. So pi. And the second, 2 pi. The third, 3 pi. What about here? Exactly. Negative pi, negative 2 pi, negative 3 pi. And then you do the sketch. That's omega. And that's the 0. And that you can write here pi, 2 pi, 3 pi, minus pi, minus 2 pi, minus 3 pi. At 0, the magnitude is equal to 0.5. So I make 0.5. Let's say that's 0.5. At pi, you have 1 over pi. What's 1 over pi? It's like 0.3 or something. That's 1 over pi. Just make it like that's 1 over pi. At 2 pi is equal 0. At 3 pi is equal minus 1 over 3 pi. That would be really very small. I mean, something like that. Let me just clear this one. 3 pi will be something like that, something very small. And then what I'm going to do on the negative side, just the reflection, the same thing, 1 pi, 1 pi, 1 over pi. That was 0, 0. That was negative, negative. Just even function. That. I'll get you back the screen, but just I want to move this one the bottom here. Now that's the magnitude. What you call it? DK magnitude. What you call this graph or this plot? You call it magnitude spectrum. Okay. What about the phase? Well, you do the same thing here like that. The phase is really easy in this one. At 0 is 0. At pi, it's 0. All right. At 2 pi is 0. At 3 pi is equal to pi. So that's pi. How you do the negative frequency? Simple. You reflect and then reflect again. Like, I mean, all zeros. And that should be pi. You make it negative pi. That's it. So what we call this one? That's the angle of decay. And it's called phase spectrum. Phase spectrum and magnitude spectrum together, we call it line spectra. And that's the beauty of the exponential complex Fourier series. Just you do it just one time like that. You don't have to square AK, BK, no, just direct. And that's what you need in the end. When you want to look at the graph and see, okay, what is the magnitude of DC or fundamental? And 3 pi, when you say 3 pi, the phase angle is equal pi. What does it mean? It means that whatever the signal you are going to put, the third component is going to be shifted by 180 degrees. Like if you are in an angle 40 degrees, will be shifted by pi. It will be like at not an angle 40, it will be an angle 40 plus 180, 220 degrees. So you know what should happen. So I can ask you, okay, what about the third component? Third component, the amplitude is equal negative 1 over 3 pi. It means if you have component in the input equal to 1, it will be flipped. Okay. Now, if you ever talk about magnitude, yeah, will be like, no, I'm sorry, I did hear something here. I should not, there's a mistake. Because I mean, the negative is a sign, the magnitude is that's mistake. That's a mistake. I did the angle and magnitude together. No, the magnitude is equal 1 over 3 pi. That's good. I review this one. 1 over 3 pi. 1 over 3 pi. I should not put the sign is the angle, not the magnitude. Because when you put the absolute value, the negative sign will be gone. It's in the top. I already take care of it. Pi. That's the angle. So every magnitude here, it tells you, I mean, about the magnitude of the component you're going to see in the output. What's the magnitude? So as I said before, when you want to design a filter, then you design your filter in the right way. Yes.
I didn't quite catch where we calculated the angle of
the angle. I mean, okay. When you have an integral like that, when I say 5, negative 5, 5, you can how write it as a vector? 5 on angle 0. Negative 5, 5 on angle 180. Why? Because e bar j 180, what's equal to? Cosine 180 plus j sine 180, right? What's cosine 180? What's sine 180? Okay, let me take, that's -1, by the way. Cosine 180 -1, not 1.
So did we take pi because that was the...
Because negative sign. Negative 1 means even if you have unit circle like that. That's 1, that's negative 1. 1, it means angle 0 or 2 pi. Negative 1, it means pi. Right?
So we went from negative pi to pi.
What do you mean from negative pi to pi?
We have negative pi to negative 3.
Yeah, because I mean, because we said that the negative frequency for the angle, you change the sign. It's an odd function. Why I get what? The angle of 1 over pi? Are you talking about the decay 1 over pi? Yeah, it's positive. It's positive. Positive 1. What's positive 1? What's positive 1? Here you go. Positive 1. What's positive 1? 0.
I don't know where to pi.
Well, I mean, what is decay here? What's the value? 1 over pi. What's 1 over pi? 3 point something, right? 3.14. Is positive or negative? What does it mean positive? Angle 0. I just ask you now. What is 5? What's the angle of 5? Okay, let me tell you something. Can you sketch 5? And if you have the x and y, real and that's the real, and that's the imaginary. Let's say that you want to sketch 5. How you sketch 5? Vector equal 5. How you do it? You get an 5 and then you connect from the origin up to here. That's 5, right? What's the angle of this vector? All right. Negative 5. What's the angle of this vector? Yes, because the angle here is over 180. It's a positive number. Yes, any positive number, it means angle 0. 180. Yes. Yes, but I just want to show you to you why. Yeah. Yes, any positive value, it means when you make the vector be like that in this direction, 0 degree. If we make negative number, it will be like in the other direction on 180 degree pi.
So if it's even 0, so why is our k of 1 not pi?
Q1.
Well, for our decay,
When K1, well, you have 1 over pi. I just answer him. 1 over pi is a positive number.
yeah, so
So the angle is 0.
So it's just on the x-axis.
Oh, in x-axis, that's right. In x-axis in the positive direction. Because the other one x-axis in the negative direction.
and how did we get that of the value of pi?
How we get what? The value of pi?
Like, yeah, we're
Using -1/3 pi, how do we get pi? Because it's
Yeah, talking about negative. Well, if you have the value D3 is equal -1 over 3 pi, you're talking about that, right? All right. You have a magnitude and you have an angle. What is the magnitude? What you do when you get the absolute value? Square root what? It's only one value.
You square it.
No, I mean, square root if you have real and imaginary. If you have, I agree with you, if you have 3 plus j4, and I ask you to find the magnitude, you will say 3 squared plus 4 squared square root equal 5. But now, when you have 1 over minus 3 pi, let me take a negative number. When I ask you what's negative, what's the magnitude of this one? 5. If you like to square, that's okay. Look at that. -5 plus j0. So what you have? -5 squared plus 0 squared square root. You want to do that, right? Okay. Fine.
So
But will cost you time in the exam.
it's, well, given the magnitude of that, you still have 1 over 3 pi.
Yeah, exactly. When you have the absolute value, you just get the magnitude. Will be 1 over 3 pi.
And then it becomes the angle of pi because.
Not the angle of pi. Angle. Oh yeah, yeah. Angle is equal pi. Yeah.
Okay,
-1. Yes, that's
and
fine.
that's because it's 180 degrees.
You can write 180 degrees if you like. Yeah. Okay. It's one. Yes. Yeah. In the negative direction. Yeah. Okay. Let me have an example. I will give you now the spectrum, and you find the exponential series, Fourier series, the opposite. Let me show you what I mean by that. Let's say that when we did the spectrum for the magnitude and the phase, that was K, and let me sketch it like at 0, the magnitude was 4, and the phase was 0. And then at 1, 2, 3, 4, and it was 0, 0, and 3 was equal to, and that was equal 4. -1, -2, -3, -4. The phase was 0, 0, 1, 2, 3, 4. At 3 was pi over 2, and at 4, -pi over 2. The question is, this is the magnitude, and that's the phase. That's d k magnitude, and that's the angle d of k. The question is, write the exponential complex Fourier series. Right? The corresponding complex exponential Fourier series. Okay. Pardon me? Okay. No, it's not quiz. It's example. Don't worry, I will give you quiz. Don't worry. You're not going to miss it. I know. I know. You don't enjoy your day till you have the quiz. Pardon me?
never found the negative value for
Oh.
would that just be reflected?
Yeah. Okay, now, I mean, to do that, first, I mean, what does it mean that you write the complex exponential Fourier series? Okay. Well, we know that x of t in general is equal to g naught plus the summation k from minus infinity to infinity except 0. I already got. And you have dk e power j k omega naught t. Okay. So to do that, how many terms? I have up to 4. I have up to 4, right? I have 0, 1, 2, 3, 4, nothing after 4. So I will do from k minus 4 to k plus 4. So it should be like that. X of t should be equal d naught. I will start with the negative, of course. d minus 4 e power j what? Minus j 4 omega naught t. I'm substituting here by the value of k. And I'm starting from the negative. All right. Plus what comes after that? D negative 3. But just you got to save your time. First, you want to find the negative value here for the amplitude for the negative frequency. I said we reflection will be 0, 0, and then at 3 is equal to, you will have 2. And at 4 it was equal to 4, you will have also 4. So I did finish. So when the amplitude is 0, I'm not going to include it. So actually I have the minus 4, minus 3, and 0 only. So minus 4 and minus 3. Let me go back. Minus 3. How you write minus 3 will be e power j and k is equal to minus 3 negative here 3 omega naught t. The same thing. I mean, I have d naught here. I mean, if you wish, I can put it there, but I like to spell it like that. Then plus, I move now to the positive. I don't have 1 or 2. I have 3 again. So I have d 3 e power j 3 omega naught t. I'm substituting by k equal positive 3, not negative 3 like this one. Plus d4 e power j 4 omega naught t. That's supposed to be. That's, I mean, the series that will express this one. Now what I'm going to do, I'm just going to substitute by the values from the line spectrum. Let's see how we do that. If omega naught was given, you should substitute by it. Yes. All right. So now what's d naught? 4. That's right. So you write 4. Plus d minus 4, the magnitude 4. And the angle. Because this is magnitude, the angle at 4. Okay, we have to finish it here. 0, 1, 2, 3, 1, negative 1, negative 2, negative 3, negative 4. So at 4 or negative by 2, if flip it, will be by over 2. And at negative 3 by over 2 will be negative pi over 2. So the angle of negative 4 is equal pi over 2. How we express it? How you express it? Do you know how to express pi over 2? That's a different example. That's given. I didn't get the value of pi over 2. It's given. Yeah. Not everything has pi. No, I mean, it's just given. So the angle is pi over 2. How you express the angle pi over 2? How you express any angle? No, if I say 30 degree, 40 degree, pi over 2, pi over 4, how you write that? No, I'm not saying to convert. I mean, how you express it in an equation? Use Euler form. Would be E power j the angle. E power j theta, it's the angle. Because the magnitude of EJ, anything is equal 1. I'm going to talk about it in the quiz. E power j theta, the magnitude is equal 1, and the angle is equal theta. All right, keep this in your mind. Now, so now what I did, I expressed d4, d minus 4, the magnitude and the angle. And then don't forget E minus J 4 omega naught T. That's that I finished D minus 4 e power minus g. Okay, plus, if you didn't get it, get this one. D minus 3 has a magnitude and an angle. What is the magnitude of D minus 3? 2. So you write 2. E power g, prepare yourself for the angle. What is the angle of when at negative 3? Negative pi over 3. So you put j negative pi over 3. Over 2, I'm sorry. And then don't forget e power minus j 3 omega naught t. That was there. I'm writing the old term. Okay. If you understood 50%, go ahead for D3 plus D3. D3 has a magnitude and an angle. What's D3? Magnitude is equal to, you put 2. And prepare yourself for the angle. What is the angle of 3 pi over 2? So you put pi over 2. You already have j. And what's next to it? D3 e power j 3 omega naught t. The last term. D4 has a magnitude and an angle. D4 magnitude is equal 4. You put 4 and prepare for the angle EJ. Then you wait for the angle. What's the angle? Negative pi over 2. Negative pi over 2. And don't forget, it D4, it's attached to E to the power of J 4 omega naught T. So the first you write the series from the spectrum, then you start to substitute. Okay. Now, I will start to organize a nice way. That's 4 plus 4. I'm looking now for this term. 4. Combine them together. E, and you take j minus j outside as a common factor. You have j and j. Take minus j, and then open bracket. What you have minus j here? 4 omega naught t. Right? 4 omega naught t. And this term next to it, e power j pi over 2. You have minus j outside that as a, so it'll be minus pi over 2. Okay. If you didn't get 100%, look for this term plus 2 e. Look for the term that has omega naught. She has plus j or minus j. If it has minus j, take it outside the common. That's the rule. Yes.
Why does that have a 2 as a coefficient, like a coefficient in front of it, but there's a 3 up in the second j term?
Are you talking about this one? 3?
The second term we got 2e raised to the j, and then you got the e raised to the negative j.
That's what I did here. I mean, that's I mean the expansion for this series from -4, -3, 0, 1, 3, 4, like that. Okay. Now look for this term. You got minus j common factor. What's left? 3 omega naught t. 3 omega naught t. And you have minus j will be plus pi over 2. Let's look at this term that we have. That's 2 e power j or minus j. So you take it j. Bracket 3 omega naught t. 3 omega naught t. And this one j pi over 2. So plus pi over 2. The last one 4 e. And then you have j. Open the bracket 4 omega naught t minus pi over 2. We're done with the second part, or the second step. Getting closer. 4 is 4. Now you start to look if you have angles are the same, put them in one term. Like what? That's minus j4 omega naught t minus pi over 2. And here you have 4 omega naught t minus pi over 2, the same angle. But one is positive, one is negative. So to make it, I mean, I like it, the way things look, it affects. So I will do that. I will say 4 omega naught t minus pi over 2. I will call it theta 4. I'll call it theta 4. And look at this one. 3 omega naught t plus pi over 2. I will call it theta 3. Now I'll write the equation in clean form. So I will have dk equal 4. Then that's 4. The second 4 will be 4 e power minus j what? 4 omega naught t minus pi over 2 theta 4, right? All right. Now I'll go move to the other term. This one 2 e power minus j 3 omega naught t plus pi over t, which is theta 3. So e power minus j 3 theta. I'm stick to the sign. I don't change this term plus 2 e power j. What's inside theta 3? Plus 4 e power j. What's inside? 4 omega naught minus pi of 2, theta 4. Okay. Look what you have here. It's clean, much cleaner. I still can continue to simplify them all. 4 is 4. Now collect theta 4 together. You have e power minus j theta 4. You have e power j theta 4, and 4 are common factors. You have 4 e power j theta 4 plus e minus j theta 4, right? Yes. Plus the last two terms, 2e power minus j theta 3, 2e power j theta 3. So you have 2 as a common factor, e j theta 3 plus e minus j theta 3 equal 4 plus 4. What's e j theta plus e minus j theta? It's cosine, 2 cosine thing. You don't believe me, right? Let me show you. I know you look at how we got this. Okay. That's cosine theta is equal half e j theta plus e minus j theta. So you can say e j theta plus e minus j theta equal to 2 cosine theta. Okay, I'm not cheating you. 2 cosine theta. Go back. So you have here that this term would be 2 cosine theta 4, and the other one will be 2 cosine theta 3. So you have 4 plus 8 cosine theta 4 plus 4 cosine theta 3. That's the answer. If you want to make like more, take 4 as a common factor. So you got 2, you got 1 plus 2 cosine theta 4 plus cosine theta 3, if you wish to do that. And you know what's cosine? If you like to write it in a formal way, that you say 4 plus 8 cosine theta 4. What's theta 4? Theta 4, we have it here, 4 omega naught t minus or plus minus pi over 2 plus 4 cosine 3 omega naught t plus pi over 2. That's the Fourier series. That's a complex exponential Fourier series terms that the question asked about. It's clean in the end.
But when you were saying 4 plus 4 times 2 cosine, where did you get the multiplication of 2?
Because we just, I show you the proof. Let me show you again. Cosine theta is equal to e power j theta plus e power minus j theta over 2.
Oh, so you moved the 2 over.
I just see, I put the 2 here and then I got, yeah. So that's, the expression that you have. You should be able to do both direction. Like if your spectrum is given, you can get the series. If the series is given like that, try it at home. Can you plot the line spectrum from this equation? That would be good. Of course you can, because that's cosine 4 omega naught t. That's the harmonic 4, the fourth one. This one 3 omega naught, that's the third, and the rest are zeros. The magnitude is 4, the magnitude is 8, the magnitude is 4, and just to continue, right? So that was like one problem that interesting how to do the opposite. Let me now. Do you have time?
Please say you know. What was that other sign thing that you had at the top? You had the cosine theta equals to half, and you had sine theta equals 1 over 2j.
Yeah. Let me. Cosine theta is equal to e j theta plus e minus j theta over 2. So if you multiply by 2 here and there, so you have e plus e j theta plus e minus j theta equal to cosine
And then
theta.
you had 2 sine ones as well.